All right, so now we're still in section 11.1, but now we're going to deal with the graphing, okay? Graphs of exponential functions, so graphs of those exponential functions look like this, where they kind of curve up, or they curve down, or they can go in the other direction as well. But really, it's almost like a half a parabola in one direction or another. Okay, so when we're looking at these sorts of functions, exponential always have horizontal asymptotes. Because as the input gets smaller, the output gets closer and closer to a single number. So here, if we look at this, right, if I go and my input is x, right, as we go up, it gets further and further away, but as our input, which is x, gets smaller, notice we have 1, we have 0.2, 0.00, 0.008. So if in this one, we're getting closer and closer to 0. So as the input gets smaller, so our x's are like our input, our output, which is our y's, gets closer and closer to something. In this case, it's getting closer and closer to 0, and 0 is the most common number for it to get closer to. And this here is an example of 5 to the x, and as you can see, we're getting closer and closer to 0. So the general formula for exponential is y equals b times a to the x plus d plus c. Now, if you don't memorize it, this is fine, but you have to know these pieces and what they really mean, okay? So if b is negative, so in other words, if we have a coefficient out front that's negative, it reflects. So if my b is negative, it reflects over the asymptote. If a is negative, so if a is negative, in other words, the thing being raised to the exponent, so if the thing being raised to the exponent is negative, or I should say a, which is the thing that's raised to the exponent, this tells if it's growth or decay. If growth or decay. If a is positive, it will be growth, which means it'll start low and move high, looking like this. If a is negative, it's decay, which means it will go down as you move to the right, and it will look more like this. C shifts the point up or down. So this piece here shifts it, and to be honest, that is actually the horizontal asymptote. So my horizontal asymptote comes from what's added at the end, just like in the rational functions where the degree of the denominator is bigger. So y is equal to c. In other words, it's equal to the number added or subtracted at the end. And then d, right? D, which is the piece up here, right? The d shifts it side to side. Shifts side to side. So if we want to know which direction it shifts, we look at the exponent. It's in the exponent, it's the thing added or subtracted to the variable in the exponent. And it does really work in opposite directions. Works in opposite directions. So if it were subtraction, it moves it to the right. If it were addition, it moves it to the left. So the opposite of what you would think, because right is normally positive and left is negative, but it moves it in the opposite direction. Okay? So that's the pieces of it, and that will help you when you go ahead and graph this. So graphing must do whenever you graph, even if it's not instructed in the homework. So you have to state the domain as your first step. The domain is the allowable x values, and it's always all real numbers. So we have an exponential function, so I can right away say domain is negative infinity to infinity, because every single number will be okay, because you can have any number in an exponent. Then the second step would be to find the horizontal asymptote. Now remember from before, the horizontal asymptote is that thing that's added at the end. So in this case, the thing that's added at the end, there's nothing at it, so we can say, well, what could we add? It would be 0. So my horizontal asymptote will be y equals 0. Then we need to state the range. In other words, what are the y values that are allowed? So my next step is to think about range, which are my y values. Now the easiest way to do that to me would actually be to kind of skip to the next step and use your graphing calculator to create a table of values. So we can create a table of xy values. So we go to the y equals, clear it out. So we have 2 to the x power, and we can go ahead and graph that. So we see that it's going up, so let's go to our table. Now when I look at my table, I was going towards the negative, right? Look, as I go towards the negative, it gets closer and closer to 0. So I don't really need to put all of those on there. Maybe I'll say, let's get where we're getting closer to 0. So negative 5 looks like a good one. So negative 5. No, you know what? Let's start at negative 4. Negative 4 was my first 0.01, so that works. So 0.06. Negative 3 was 0.12. Negative 2 is 0.25. Negative 1 is 0.5. I'm going to move that over so that I can keep going. And then 0, 1, 1, 2, 2, 4, 3, 8. I could put 416, but it would end up off my graph, so there's no point in plotting that. So my horizontal asymptote, I should go ahead and put that on my graph, is y equals 0. So that means I'm going to put a little dotted line here, really close to 0, so that hopefully I can see it. Okay. So I should get closer and closer to 0 without touching it. So 3, 8, 2, 4, 1, 2, 0, 1, negative 1.5, 2, 5. And really, I don't really need to do much more than that. We can just kind of show that we're going to get closer and closer, but never actually touch 0. All right, so we'll do one more example, and then I'll have you try the other one on your own. So the next one, again, we're going to state domain first, and domain is always negative infinity to infinity. Right? Then we have to do our horizontal asymptote, which always comes from what's added at the end, so y equals 3. And I can go ahead and put my line there. Okay, then we're going to do, oh, I forgot to do range on my other one. I forgot to go back and do range. So range was from 0, never touching 0, but getting close. So it's from 0 to infinity here, because we got close to 0 without touching it, and it kept going up. So my range here will actually more than likely be from 3 to something, but let's wait and see based on our XY table. So we'd go here, and we'd type it in our calculator. So y equals, and then it'd be 2 to the x power plus 3, and we can see what the graph looks like. Okay, and go ahead and go to our table to get that value. Okay, so I'm going to start this at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2, because that's the last one that'll fit. So 7, 5, 4, 3.5, 3.25, 3.12, 3.06, 3.03. So again, you can see that you probably don't need to graph all of these. So I'd go to 2, 7 and make a point. 1, 5, 0, 4, -1, -1, and then 3.5, -2, 3.25. I'm not going to go much beyond that because there's no point in doing so other than I need to fix this was 2, 7 here. So this is what my graph will look like. So that tells me I'm going to get close to 3 but never touch it, and y will be going up until infinity. All right, so now what you're going to do for homework is you're going to try and do that same thing here with the e of x. It's the same basic idea, but now instead of typing in a number, your base is e. So go through those same basic steps, and you're going to try this one on your own. And we'll go over anything that you don't understand tomorrow in class. So have a good night.